you hear me? Or is the mic not working? All right, cool. Thanks. Welcome, everyone. Second talk of the day. I didn't know I was going to be after Troy, so now I'm more freaked out because I'm not as good a speaker as Troy, so just heads up on that one. Quick intro while people are still getting some food. I'm Dev. I was at Berkeley getting a PhD in application security and browser security. Then I moved to Dropbox, where I now lead product security and abuse prevention. And this is my website, and that's my Twitter handle. So say hi on Twitter if you. The other thing is Dropbox paid for my flight, so I do have to do the obligatory. We are hiring, and it's a great place to work. I can talk more, but we're definitely hiring, and that's all we'll talk about because that's enough for the flights. Quick disclaimer on the talk, everything I say is my own views, not representing my employer. I also didn't do much of the work, other people did all the work, but if there are any mistakes in the presentation, these are all my mistakes. I'm more like this dog at the end who's just watching everyone else do the work. I'm the manager in, in security engineering at Dropbox, so everyone else did the work, just a heads up, I'm just talking about it. Which is a nice job to have. Another warning, so I'm a recovering academic. As Jim mentioned, I got a PhD. And I went from academia to the industry. And this pretty much sums up like the, the transition, right? Like this is, academia was the top, and now this is the real world. Duct tape, pretty important. And so this talk is about engineering. It's not about science. It's going to be a bunch of hacks. Please don't, I mean, you all work in the industry, so you're not going to be surprised at hacks, but just heads up. It's not going to be a beautiful crypto theorem being proved here, so just heads up on that. All right, a prelude about what's the sort of problem I'm trying to solve, right? So this is my friend GC. He works at Dropbox in the marketing team. GC is awesome. I love GC. He's, I'd do anything for him. And one day he came to me and said, can we run a CMS, a content management system, on /enterprise? Now, how many of you know what a CMS is or what content management systems are? All right, yeah, so how many of you smile and are charmed at the thought of CMSs? And so, my reaction was like that. And GC had, to his credit, a simple idea. He was saying, like, look, Nginx, the / we route upstream to our app server. And let's just tell Nginx, if it's /enterprise, go to the CMS. Sounds easy, like, right? Like, that's not very hard. I'm in security. My reaction was more like, you do not simply do that. And I started off with this, the Dropbox rewards program. So Dropbox is one of the best, I think, best bug bounties, but also one of the highest bug bounties on the internet. So our bug bounties are higher than most of our competitors. And so we pay out like $33,000 roughly. The numbers are weird because we only pay out in cubes because box, but roughly 33,000 when it comes to bounties for RCE, for example. Or cross-site scripting is roughly 12,000. And so that's a significant chunk of money, right? And when I look at this architectural diagram, the main app server, the Dropbox app server that security engineering has worked on, has all these features. We have CSP, ORM, same site, like pretty much every modern AppSec feature you can think of, we probably have adopted, right? Because we take security pretty seriously at Dropbox, and we believe in defenses in depth, and so we have a lot of this stuff locked down. And when I think about the CMS, I don't know, what's the state? So then let's do a quick Google, right? Like go to Google and ask, hey, on the OSS security mailing list, how has CMS fared? And there's a long list of issues. Many of them are RCEs and XSS. If I look at Drupal, which is one of the most popular CMSs out there, a lot of issues, most of them XSS, but definitely a bunch of remote code execution vulnerabilities. And that would be a tremendous risk for Dropbox to adopt, right? It's really unacceptable, right? Like, so I was, I like to think of myself as Asher. So I said, like, look, this is not OK. This is pretty dangerous. I really cannot be comfortable with this. But the thing about Dropbox security is we pride ourselves culturally on what we call solving for yes, right? Like, we don't like to say no. We like to say yes. Let's do it this way. Let's figure out a way to do it, right? And so we started thinking, and we said, like, maybe we can do something here, right? Like, maybe there is some nugget of an idea that we can adopt here. And the nugget of an idea comes from this classic idea of compartmentalization or isolation. This is a slide I found on Google on, like, fire compartments. So you have compartments in buildings to limit the damage of fire. And so similarly, we can do something similar on this CMS. right? And so you take this architecture and you strip all sensitive cookies before making the request to the app server, and then you put to the CMS. You put the CMS in a completely isolated AWS VPC, fully different from our main app server and everything, and you put very heavy firewalls, sandboxing, monitoring, everything, all the security things you can throw on top of it. You lock it down, right? And so in terms of fire compartments, if that burns, nothing bad can happen, right? Like it can't really hit our main app servers, it can't hit our databases, it can't really do anything. The VPC, the AWS VPC has nothing in it. And so it's pretty locked down. Does this make sense? I've been moving very quickly, but this is all prelude. So you put the CMS in some place far away and you close your eyes and hope that nothing happens, right? And so then it's like, are we done? And as you can see from the image at the end, we're definitely not done. The reason we're not done is if I think about how the browser sees this architecture, the browser does not know about AWS VPCs, what all is happening behind the scenes. For the browser, the CMS, the app server, everything is on www.dropbox.com. It's all the single origin. And so for the browser, if there's an XSS in the CMS, and it's as good as an XSS in the main Dropbox.com application. Browser does not compartmentalize. The browser does not isolate. The browser, everything is the same. Browser does not care it's a separate AWS VPC or anything like that. And so this is where, like, thanks, same origin policy, right? Like, you screwed us over there. This is horrible, right? So even if we lock down the CMS, if the CMS has an XSS, we are host. And so, OK, how bad is XSS, right? Like, so again, OSS security, CMS XSS, lots and lots of issues. That Drupal image I showed earlier, half of all CVs reported, roughly half of all CVs reported on Drupal, XSS. So XSS in CMS is very, very common, right? And it's easy to say, hey, what's the big deal? Who cares about cross-site scripting? It's not like remote code execution. It's not like SQL injection. It's a client-side vulnerability. And so what can XSS on Dropbox do, for example? Right, so the thing about XSS, because most examples online are about alert, people don't realize XSS is actually a really powerful vulnerability. It can, a cross-site scripting one can allow the attacker to do everything a user can do. And in the case of Dropbox, read the password as you type it, authorize API apps that steal your data, share all your data publicly, delete all your files, permanently delete all your files. All these things can be done completely with a cross-site scripting attack. So that's really not OK. Right? Like, we're really not happy with this sort of risk. That's why on the main Dropbox website, our bounty for an XSS is roughly $12,000. We have CSP, we have React, we have multiple layers of defenses, because XSS is really bad on Dropbox. So that's terrifying. We don't want to end up with this. So what do we do now? People following till now before we jump into the solution? All right. Again, we started thinking, OK, is there something we can do in terms of compartmentalization, isolation? And again, the fire compartment idea came in mind. So the easiest way to isolate, to compartmentalize, is to do something like a separate domain, right? Like, you must have seen this, right? Like, you create a new website, right? Instead of using Dropbox.com, run the CMS on dbxmarketing.com. Completely separate domain, completely isolated domain. So the browser treats it as a separate origin. Any XSS on dbxmarketing.com cannot hit Dropbox.com. This is a classic technique used in many, many places. This is not great for SEO or branding, right? Like, you're spreading your SEO positivity on multiple domains, right? So it doesn't work well for search ranking and stuff. And subdomains feel slightly better, so maybe we could do marketing.dropbox.com, but then you're not actually getting full isolation. And GC, my friend GC, initially wanted to run it on /enterprise. He wanted it to be dropbox.com/enterprise. That's pretty. That's good SEO. And to move it to a completely separate site or a completely separate subdomain kind of is saying no to him, which is not a great feeling. On a side note, I also point out that as security, I do feel like we all, like a lot of the community says, like, oh, separate domains are great. You should put in a separate domain. I do wonder whether that's actually true. Do we really want to train our users that there are all these different websites with different weird names that are actually trusted? Those are actually valid, right? It makes us feel better in terms of cross-site scripting, but I'm not really sure it helps our users, right? As an example, if these are the list of sites, and there are companies, I'm not going to name them, who have something similar because they isolate every domain, which one of these is the phishing site? Anyone have a guess? It's actually companyblogs.com, and it's a simple phishing because the L is actually a capital I. So, and like, yeah, why would a user notice, right? Like, and you're training users that like, oh, company.com, companymarketing.com, companycustomercare.com is legit, but companyblogs.com when the L is I is not, like, that's insane, right? And I just don't, I'm not personally a fan of like this massive increase in the list of domains. I do wonder about the security risk there. So we go down to our core problem again. Can we serve this CMS page that could have an XSS from www.dropbox.com without really destroying our security guarantees, right? That's the question that I'm really trying to answer. What can we do here? So 2018, you're a web application person, and you need to solve some security problem in WebAppSec. What spec is the answer to anything security in WebAppSec in 2018? Well, it's CSP, right? Like, everything you want to do is in content security policy. And so thankfully, there is a thing in CSP for this that I wanted to talk about today. And this is called the CSP Sandbox. How many people have seen or used the iframe sandbox? Awesome. So the CSP sandbox is an extension of the iframe sandbox, and I'll explain both in a minute. But the basic idea of CSP sandbox is to set the iframe sandbox with a header, so you can send it as part of the page. And all that the sandbox tells the browser is that treat this page as if it's a random null origin, right? Treat this page as it's an unknown randomized origin. I like to think of it as a 128-bit random origin. Inside, if you dig into Chrome and Firefox code, it's actually treated as the null origin. But think of it like a random 128-bit origin. And a random 128-bit origin is never equal to any other origin, right? Like, it's a completely random number. And so that's how the null origin or the sandboxed origin is implemented in browsers. It is never equal to any other origin. It's always cross-origin to everything. And so if you think in terms of same origin policy, an XSS on like a null origin cannot really do anything bad because it's completely different from every origin. It's not equal to www.dropbox.com. No. I mean, there's a nuance there, but yeah, I'll get to that. Sorry? Oh, yeah, so the question was, can it be equal to another null origin? And if you look, I'll get to it. I mean, just the TLDR is like, except for cors, everywhere else it's not equal to another null origin. So if you have two iframes, let's say, that are null origins, they can't actually script each other. They can't like reach into each other. For example, if you have two iframes that are both dropbox.com, they can go in and touch each other's JavaScript and variables and everything. But if you have two iframes that are null, they can't actually go into each other and touch each other. But there is an exception in cors. But other than that, it's mostly every null origin is also separate from every other null origin. Does that make sense? This is a really important like part of the presentation, that there is this concept of the null origin that you can use. And by setting a CSP sandbox header, you can tell the browser, hey, treat this as the null origin, which is cross-origin from everything. Sorry, question? Yeah, so that's my next slide. Great. So this is one of the best parts about this header is actually it's widely supported. As early as IE10 supports CSP Sandbox. In IE10, you have to do X-content security policy to get it to work. But if you dig around, you can get the like right set of headers so that you get sandboxed origins on all browsers, which is kind of cool, right? Like as security professionals, there aren't that many specs that you can rely on that work. XSS works on all browsers pretty reliably, but security specs, it's rare to find one. So it's pretty great, right? Everyone with me? I'm moving fast because I know I'm holding back from the snack. So I don't want to. I'm balancing understanding, and you will hit me if I. CSP Sandbox, not CSP support. Yeah, IE10 does not support CSP, for example. It only supports Sandbox via CSP header, but none of the other CSP primitives. Instead of, yeah, that was IE9, IE8, I think, but yeah. Sorry, so the question was, is this just CSP Sandbox support or is this CSP support? And IE10 does not support remaining parts of CSP, it only supports CSP Sandbox. Do you have a question or? So the question was, did I consider using X-frame options? It's trying to solve a different problem. That's about allowing framing, whereas this is about saying which origin to run this page in. So like different problem, yeah. So we do use X-frame options everywhere, right? We use frame ancestor CSP everywhere. That's for like clickjacking and who's allowed to frame. This is about, this null origin is about what principle to, like in terms of operating systems, which user ID to run this app in. That's kind of closer to what this is trying to achieve. All right. So what is this magical header that you can set? All right, so you start with content security policy, of course, and then you say sandbox. This tells the browser, run this page in a sandbox in the null origin. You also want to say allow forms, because by default, a sandbox is super secure, so it does not allow even forms to work. And because any reasonable page would usually have some form, in our case, the marketing page has a contact form, you want that to work, so you say allow forms. Then you also say allow scripts. By default, sandboxes cannot run any script. So you say allow script to say run it in the null origin, but allow it to run some script in the null origin. Otherwise, it's not a very interesting page. It's a static page. And then you also say allow top navigation. Sometimes when you are sandboxing an iframe, you don't want to allow top navigation, but in our case, we are sandboxing the whole /enterprise CMS. So we do want it to navigate when a user clicks a link. So you also say allow top navigation. And we also say allow pop-ups, because if there's a contact us form, there's often a pop-up that says go here to contact us. Yeah. So there is no new domain right now. So dropbox.com/enterprise is /enterprise, but it's set as a header in this policy. So concretely, here's what happens, right? So you make a request to dropbox.com. If it's a request to like /foo, it will go to the app server. If it's a request to /enterprise, it will actually go to the CMS server in an isolated VPC, firewalled off, isolated, like, bad things could happen there. And this server responds back with the HTML, and we have a shim in the middle that adds a CSP header, the previous CSP header I said, content security policy, sandbox, blah, blah, blah. So, but this is www.dropbox.com/enterprise. This isn't another domain. This is dropbox.com. And when that request response goes all the way back to the browser, a browser knows that because it came with the CSP sandbox header, treat this as the null origin, isolated from everything else. And so even though it came from dropbox.com, the browser is going to treat it as a random, isolated, null origin. Does that make sense? All right. So you do this, and it works. You go to dropbox.com/enterprise, and you can go right now if you want. But actually, don't. My talk is great. Listen to me. You go to dropbox.com/enterprise, and this works, right? Like, this is a classic marketing page. Our marketing team has built it. It has all sorts of widgets, but it's on /enterprise. It does not have any of the privileges of code running on dropbox.com. It cannot, like, change the user settings or anything like that. It's completely isolated. It is running script. It is interactive, but it does not have any privileges. Which is awesome, right? Like, it's great. I was feeling awesome. But no fairy tale ends that quickly. So as soon as we turned this on, there were bugs everywhere, like lots and lots of bugs. Why is that? So you open up your Chrome console and see what's happening. And you get a bunch of these exceptions. Fail to read session storage, fail to read the cookie property. And that makes sense. The way a sandbox is designed is that it is a null origin. It does not have access to cookies of dropbox.com. It does not have access to local storage. It does not have access to session storage. Another thing that's not in this list that break is XML HTTP request, because every XML HTTP request you make is cross-origin. All the XHRs stop working. So every XHR is a CORS request, it breaks. All storage primitives break. So the page kind of works, but you want to do something interesting beyond just like fancy animations inside the page. You want to make a request, you want to log something, you want to store some state, that stops working. So this is not great, right? Like, a proper CMS will probably want to use some state storage. A proper CMS will probably want to make an XHR, and this sucks. And so we we needed to do something here, and it was time to start hacking. And so these were our two problems, right? Like getting XML HTTP requests to work and getting state storage to work. And let's tackle them one by one. So XML HTTP request. What we did for fixing the XML HTTP request is you just redefine the XML HTTP request constructor to implicitly add with credentials equal to true if you're hitting www.dropbox.com. Because it was a CORS request, it wasn't adding the cookies by default when running from the null origin. So you redefine XML HTTP request. JavaScript is a great language. You can redefine all the constructors you want and like shim them. So so you redefine it to say like, hey, implicitly add with credentials equal to true if it's making a request to dropbox.com. So this kind of starts matching the same origin XHR behavior. And so now you make a CORS request to dropbox.com with the origin null, because again, this is running in the origin null. So the CORS request won't go up with origin dropbox.com. It will go in with, origin null. And the server can then respond with access control allow origin null for the client to read the response. How many people have played with CORS and know why this is a terrible idea? Okay. So yeah, this is a very, very bad idea. Do not do this. Because when you say access control allow origin null, you're saying any null origin on the internet can read this response. And so any website on the internet can sandbox a page and hit this endpoint and read the response. This basically destroys the web security model completely. I mean, model is whatever web security model we have. So, and so what we did was, okay, in addition to implicitly redefining with credentials to true, we can also implicitly add to the XHR a CSRF token. This CSRF token only allows you to make the request. And so we actually use a derived CSRF token. We derive an HMAC from the actual CSRF token and add it to all requests. Even GET requests, even head requests, even like anything and everything. Every URI has to have this. And the server, even before it forwards the request to the CMS or the app server, it will just say, do you have the right CSRF token? If not, I'm just going to fail the request. What this guarantees is only our pages know this CSRF token. So no other website on the internet can actually make the request. And so the access control allow origin null isn't anymore a problem. But it is important that you have to protect all requests, which is different from the classic web security model. So it kind of works. Now you can say you have to do this additional thing. So we were earlier only adding the CSP headers, but we'll also add the JavaScript shims to the HTML after the enterprise CMS response comes in and redefine XML HTTP request, have all those things, and then modify the forwarder to say if it's an XML HTTP request, the CSRF token does not match, just fail. So now you've kind of made XML HTTP requests kind of start working fine. You can also use this to talk directly to the app server, because often if you are building something like /enterprise, some marketing website, you actually want to ask the app server some questions, right? Is this user, in our case, is this user a registered user? Even that, like the CMS does not know because we're stripping all sensitive data. But it's like security can evaluate and say like it's a fine risk to accept that the CMS can learn whether the user is a registered user. So you can use this trick to allow the CMS to learn that also. All right, so the other problem we had was state storage. A null origin has no place to store any state. No cookies, no local storage, no session storage. Let's focus mainly on cookies. The way we fix cookies will fix everything. Local storage, session storage also. Also, I like saying cookies. So we already have a place to store state, right? The network stack, the cookie stack has the ability to store state. The actual cookies on dropbox.com. So now at the proxy, we redefine document.cookie as a dictionary. We literally say document.cookie equal to JSON dictionary with defined property getters, defined property setters that match the cookie behavior. If the page, the CMS page running in null origin tries to update the cookie, you update the dictionary. You don't actually update the actual cookie state, you just update the dictionary. But to persist the state, you make an XML HTTP request to the server and tell the server, hey, can you set this cookie? And the server sets the cookie and persists that state. So concretely, imagine I did document.cookie A equal to B inside the CMS. So first, you redefine document.cookie as a JavaScript dictionary or whatever. And when I do document.cookie a equal to b, the browser, the JavaScript in our client side, will make an XML HTTP request to /setCookie. I mean, it's actually a much more complicated endpoint, with name equal to a, value equal to b, and the CSRF token. And the server will respond with setCookie a equal to b. So very simple abstraction. Of course, this is not how it's actually done, because we like make sure to prefix every a with like untrusted enterprise cookie a equal to b. But like at a high level, this is kind of how it works. Yeah. Yes, these are the enterprise cookies, though. You can make a post request. That's fine. It just makes it easier to talk about if I say URL. But in either case, it is the enterprise cookies. These are not our actual auth cookies or such. Like those are not even accessible to JavaScript. So yeah, post is fine. Post is easier. Yeah. Everyone with me? You do like, yeah, JavaScript, you can redefine any like variable, right? So you redefine the document.cookie variable to be this new object that actually maps to a JavaScript dictionary. And JavaScript has the concept of setters and getters. So for the setter, you say, all right, update the dictionary, but also queue up a task to make this XML HTTP request. So if the enterprise is setting sensitive information, enterprise CMS, /enterprise, the CMS, is setting sensitive information in the cookie, this doesn't change that risk, right? Like that's just CMS has a bug. I guess I'm not, yeah. Like,
I guess what I'm leading to is that then it's not HTTP.
if it, yeah, if it was, so if it was HTTP only, this wouldn't happen anyhow, so yeah. Okay? All right, so I think we have time for a quick demo. Let's try this. As usual, best practice is to, all right, let me know if I should increase the font, but, right, so this is, as I said, right, like it seems to work fine. Oh, sorry. This is going to be awkward. All right, so this is the CMS, right? And if I do, it has all these cookies. Just to quickly show what's actually happening, let's do, you might see a sales message. Sorry about that. So I'm doing document.cookie a equal to b. This is how in JavaScript you set the cookie a to b, right? And if I do that, it will work fine. If I do, there's a new cookie at the bottom that's document.cookie, right? But if I go here, this is a bad idea. Let's see, maybe this will be fine. Right? All right, let's see. Nope. So there's actually a cookie called sandbox_c_a that's set to the value b. So it's actually not being able to set, it's prefixing everything so that there's no way of colliding with our actual cookies. And so it limits all possible damage, right? It's a simple trick, right? All right, so it's terrifying. I did not want to open my cookie jar, but all right, so summarize. You can use normal operating system standard VPC network isolation to isolate the server side, and you can use this technique of CSP sandboxing to isolate at the client side. Tell the browser, hey, this is a completely different origin. Sorry, stop showing on my side. These bunch of hacks around XML HTTP request and state kind of get the whole page to work fine. It limits all damage, and you're OK. Some stuff still doesn't work, embeds like YouTube. Because the way Sandbox works is that all frames inherit the sandbox. YouTube does not like running in a sandbox. and so it fails. But if you just use a video tag with a video you have, it works fine. It's just you can't directly embed a YouTube video, which seems to be okay with us right now. Some other stuff, embeds like that want to run privileged won't work. But that's kind of the point. We are isolating, we are limiting. So yeah, you want to run privileged, you can't do that in this. All right, so if you're sitting here being like, this is crazy, and this is insanely complicated for something as simple as doing this, you're right. As they say, I'm an engineer, I over-engineer. And so yeah, you're right. And like, I agree with you, it's horrible. And so one of the things I've been working on the side is this concept of suborigins, which is a specification at the W3C. And the essential idea of suborigins is that it should be really trivial for anyone to be able to isolate content at the client side. You should be very easily able to tell the browser, treat this as a separate suborigin called CMS or separate suborigin called enterprise. Pretty much everyone has this sort of context, right? Like maybe it's the separate suborigin called PHPMyAdmin, separate suborigin called admin. There's always some different aspects of the application you want to break up into isolated containers, and suborigins will let you do that. With the suborigin proposal, post message, XHR, local storage cookies will just work. The browser will store cookies as the suborigin, whatever you call it, not with the main origin. Local storage will work. Everything will just work. And you won't need any JavaScript hacks. There's a demo behind flags in Chrome right now that already you can play with if you want. And you can also go to these URIs to learn more about what's the suborigin. I especially recommend why suborigins to understand the context behind why we are trying to push for this. And you can talk to me. I'm here for 2 days. So I'm happy to talk more. I love suborigins as a spec. I think it's really important. And just as an example, right? Like, so instead of saying access control allow null, you can say in the suborigin world, access control allows suborigin CMS and access control allow origin Dropbox.com. That's a much stronger guarantee than allow null. You can post message. So in this case, I'm post messaging foo to the origin Dropbox.com and suborigin CMS. And the browser will only deliver the message if the suborigins match. This is pretty close to how post message works right now, but you can also specify the suborigin. So talk to me. If you are interested, you find this interesting, do email public-web-appsec@w3.org, because it's currently the big debate right now about the spec is that will this be useful to people beyond, like the couple of people have shown. So Google and Dropbox are pretty interested in it right now, but if others are interested, that would be pretty valuable to hear. Finally, before I end, the reality is the CMS we run is super rock solid, actually. Maybe I didn't need to do this. Because we use Adobe AEM, it's super rock solid. We haven't found any excesses. I actually love Drupal. I think like I could only wish to have the sort of impact Drupal has had on the world. It's great work, and I just like to think in defense in depth and multiple layers of defense. I didn't want to, I know it can sound like I was making fun of Drupal and stuff. It's not. Like Drupal CMSs are doing amazing stuff. I see how people are able to use something like a CMS, and it's really cool. And with that, thanks a lot for listening. Thank you. Happy to take questions. I don't know how much time I have, Jim. The suborigin spec is published, yeah. It's in draft mode right now, though. Yeah. It's live, yeah. Sorry, Alex. No, because XSS can't do anything. I mean, we'll limit to much fewer. Like, yeah, similar to like the server side, right? Like we have a bunch of processing that we do that is sandboxed. So if you find a bug in something that's super heavily sandboxed, we won't pay out a bug bounty. So there is some nuance there, yeah. Anyone else have a question? Sorry? So right now it's a draft spec. Only Chrome has an implementation behind a flag. So yeah, CSP Sandbox is supported everywhere, but suborigins isn't. Yeah.
So with the current solution, it implies that all of the local storage gets seen by the server, right?
All of the local storage gets seen by the server. Yes, you're right. That's a difference. Yeah. In terms of threat model, though, like server sends the JavaScript that can read all the local storage. So it's, yeah. But yeah, I know you're from 1Password, right? So I can totally see why that would be a big deal. You're right. Yeah. Oh, we have a separate derived CSR for the example CSRF token for XHR. Think of it like hashing the actual CSRF token with another secret. And no, the cookies also go. So that's the CSRF check, right? The cookie has the CSRF token, the actual CSRF token. We hash that and check the hash matches what was in the URI, and that's the CSRF check. Yeah. No, otherwise, yeah. Yeah, Justin. So because we already had to shim XHR, right, to add implicitly with credentials. In that same code, we added the adding of CSRF token. It's in the client side, right? Adding the token. That's in the proxy that forwards to the CMS and the few controllers that are in the app server. That's a. Yeah, so if you're navigating, for example, like the entry points, you don't require a CSRF token, that's true. But you're returning HTML, you're not returning XHRs, right? So, and it won't come, like you don't send access control allow origin null for navigation requests. It's only when you're sending access control allow origin null that these checks are needed, right? So, yeah. So it's a completely different CSRF token that's only for making those XHRs and nothing else. Yep, they could do anything they want inside the enterprise, like that inside the CMS. Yes, my worry wasn't the fact that they can do some. If you have an XSS in the CMS, you can do bad things inside the CMS. Yeah, kind of think of it like that. Yeah. But yeah, no, that's why it's isolation. It's not like fixing bugs. It's like if bad things happen, it will remain isolated inside. Similar to like if there's a remote code execution in the CMS, like yeah, it can take down that hole and do very bad things and deface the site. But yeah, no, yeah, it's just isolating. Yeah. I think you had a question. Any other questions? Anyways, I'm around for 2 days. Happy to chat. Thanks for your time. You have been a great audience. Thank you.